Welcome back. In this lecture, we will learn to work with the copy tool or copy command once again, but this time we will learn to implement automatic schema evolution. So let's start. As usual, I'll go to my workspace and open a new notebook for this demo. Connect with a cluster, do a bit of cleanup, and then do a setup. So we are now ready to work on this scenario. Let's look at our landing zone directory. So we have 3 files in our landing zone directory. Our ingestion tool is ingesting data into the landing zone directory and creating files. We want to use copy tool to ingest data from the landing zone. So that's what we are going to do. But this time we want to implement automatic schema evolution. So the idea is to define our bronze layer table without any schema. We want to create a bronze layer table with no schema defined initially and let automatic schema evolution take up the schema based on the data files and create the table schema, right? So how do we create a schema-less table in Databricks? We want to create a schema-less delta table in Databricks. How do we do that? Super simple. Let me copy paste command for that. Here is the command. Create table, if not exist, table name. That's all. We are not defining what are the columns, what is the schema of the table. So let me run this, and this command will create a schema-less delta table. Maybe you can describe the delta table and see what is there, right? So let's say describe and let's say extended and tell the table name. So describe extended gives me all the details about the table, but no in schema, right? So we don't have any schema, column names, data types for the column names, all those details are not there, but we have a table in the dev catalog in the DemoDB database, and this is the table name and it is a managed table, right? So we have the table in place. It's a schema-less table. What we want to do next, ingest data using the copy tool into this schema-less table from the landing zone directory, and the schema of the table should be automatically defined based on the incoming data, right? So that's what we want to do. Let's try creating a copy into statement for that. So what we want to do, copy into and just paste the table name, copy into this table, right? And then we tell copy from where, right? So from, and what is the from? In the earlier scenario we created a select expression because we wanted to define a select expression, list of column names from a landing zone directory. But this time we don't want to define a complete select statement. We just want to define the, this is my directory, this is my landing zone directory, just pick up data from there, whatever files are there, pick up it from there and build the schema at the runtime based on the data files. So I'll simply tell the location from this location without the select expression. What is the location? Location is my landing zone directory. So from this location, simple. And then we tell what is the file format at this location. So we say file format equal to CSV, and now we can specify format options. So let's say format options. What all the options do we want to specify? I obviously want to tell header is there. So let's say header equal to true. That's there. What other option I want to tell? Since we didn't define a schema for the table and we are not telling what all the columns we need to select, so I also want to leverage the power of schema inference. So I tell infer schema equal to true. So we want to infer the schema from the data files. So infer schema equal to true. What other options? I also want to tell merge schema is equal to true. So merge schema equal to true. So I'm telling the data frame reader, the CSV data frame reader, to merge the schema if different file comes with different schemas. Maybe one file comes with 5 columns, the next file comes with 6 columns. So one additional column we want to tell the data frame reader or CSV reader behind the scene to merge the schema of different files. So that's done. What else we want to do? I know I'm going to get some timestamp fields in my source files, and those timestamp fields comes with a specific timestamp format. So I also want to tell what is my timestamp format. Timestamp format in my incoming files equal to what is the format? I know my data is coming with DMY format and hour and minute. That's all. I don't have a second. So that's all about the format. What else? So copy into also comes with copy options. So in copy options, we don't have too many things, but one basic thing I want to tell the copy into command is that we want to implement automatic schema evolution. So if you get some new fields, new columns in the data source, create those columns, create those fields in my target table if the field does not already exist. So that you can specify using copy options. So let me specify that as well. Copy options, and I just want to tell one copy option, merge schema equal to true. So basically it is the same kind of option, merge schema equal to true. That's all. So that's my copy into command with automatic schema evolution configured. So what we are telling, copy into this table, read data from this directory, format of the data files in this directory is CSV, apply these CSV options and enable automatic schema evolution for the copy into command. That's all. Let's run it. So it worked, and I ingested 793 records into a schema-less table. But what is the schema of the table? That schema is determined based on the input data set. And since I have implemented automatic schema evolution using this option, the copy into will add the columns into the table. Let's check what do we have in the table. So we got 793 records, all looks good. customer ID is null for some records, but that's how data is in my files. Some records come with null customer ID, and later some record comes with the valid customer ID. So data is inserted into the table, and I can see fields also. If you want, you can describe your table, right, and see what do we have in the schema. So invoice number is now integer. It's inferred automatically. That's how the schema inference works. It found that infer schema option has found that invoice number looks like an integer. So integer, string, int for quality, timestamp for invoice date, double for unit price, int for customer ID. So few hiccups here and there in terms of automatic schema inference, but that's how it is. So we are done ingesting data into a schemaless table using automatic schema evolution in the copy into command. That's how copy into automatic schema evolution works. But let's progress the scenario. Let's ingest one more data file into our landing zone. I'll copy one more data file into the landing zone, and this data file comes with one more additional column. So we get country column in this new file, which is extra, which was not there in the earlier. So how copy will work now? Ingest data into invoices raw table again. So same copy into command should work without any changes. So let me copy it here and run it again. So it worked. 254 records are inserted once again. If you want, you can do a select star on that table once again and check the records. So we got country column at the end. Some records are null, which are old records, and new records has got the country field value populated. If you want, you can describe the table again to check how the schema evolution has worked. Let's say we want to describe the table, and you can see we got a new column at the end, which is a string, inferred as a string. So that's all for copy into with automatic schema evolution configurations. And you can use it if you have a requirement where you want to keep on ingesting new fields as they arrive into the data ingestion pipeline, and without breaking your copy into command, you keep on ingesting and keep on evolving your schema automatically. That's all for this lecture. See you again in the next lecture. Keep learning and keep growing.